All right, let's begin. This is our presentation for Chapter 1 of Economics 2013, Principles of Macroeconomics. We are using the Hubbard and O'Brien text. And what we're going to be going through here is we're going to be going through different foundations and models in economics. What is this class about? People make choices as they try to attain their goals. Choices are necessary because we live in a world of scarcity. Scarcity is a situation in which unlimited wants exceed the limited resources available to fulfill those wants. This is the information we're presented with on slide 3 of 45 of our presentation. Economics is the study of these choices. Economists study these choices using economic models, simplified versions of reality, used to analyze real-world economic applications. So if you try to imagine a situation where we only have but so many chickens in an area, and people need these chickens to live, right? Because, assuming that they're not vegetarian or not otherwise opposed to the eating of chickens, the amount of people in that area versus the amount of chickens, there's going to be scarcity. While maybe at first, maybe there isn't so much of a problem, over time there's going to be a problem as more chickens are killed, that there needs to be enough chickens to go around to feed people. So part of understanding what goes into that equation would be, how many chickens are we going to have in the future? In other words, are we just going to kill off the chickens we have and then we don't have any more chickens to work with? Or are we going to keep breeding these chickens and then ultimately creating new chickens that people can then eat at a later date? Because actually, once you kill the chicken, that's it. Chicken's gone, right? So as many baby chickens that grow into adult chickens, these ensure that we have enough chickens in the future for which people can then deal with the ability of rationing out those chickens so that everyone gets to eat some chicken. Water is another precious resource because we can't just take the water from the ocean. We have to take water from freshwater sources. So if those freshwater sources should become contaminated, if there are more people using that water than water available, then we're going to have to be very careful about what we do with that water in terms of who we allow to have it, when, where, and how. Economics questions include: how are the prices of goods and services determined? How does pollution affect the economy? How should the government deal with these effects? Why do firms engage in international trade? And how do government policies affect international trade? Why does government control the prices of some goods and services, and what are the effects of those controls? Going to slide 5 of 45, we're looking at 3 key economic ideas. The first idea is that people are rational. As in class, when we discussed the scenario of the $8,000 car, pretty much all of you indicated that you would not spend $8,000 to fix a car that was only worth $8,000. And at some point, it's not worth it, right? And for you to have made that determination, you have had to have taken a rational approach to figuring out that when the amount of maintenance and work put into a car with an actual cash value of $8,000 either equals or exceeds that $8,000, that it is no longer rational to keep pouring that much money into a car that will never be worth more than $8,000. It's not like you do the $8,000 in repairs and then the value increases to $16,000. The car is still going to be worth $8,000. For that amount of money, you can buy another $8,000 car. So it would defy logic to just keep pouring money into it and throwing money at it when in fact you are spending more than the car is worth. That's a rational way of thinking. That's a rational idea. People respond to incentives. If you give people coupons, they will rush to the store and try to use those coupons. If you tell people everything is half off, they will rush to the store to try to take advantage of that. If you tell people it's Black Friday, then people will trample each other in a mad fit to get the best bargains. Optimal decisions are made at the margin. That means that at the margin, we assume that we have engaged in some course of action, and to produce one more unit or to go to the level of one more unit. So for example, if we work 10 hours, we decide to work that 11th hour, that would also be considered one more unit. That is a decision being made at the margin. In other words, we're working with the assumption of 10 hours, but if we go to the 11th hour, we're making a decision at the margin to go one more unit. So as a result, we need to examine that, because then we can extrapolate from that, right? Because, we like with the example of the 24-hour Walgreens, we may determine that if the Walgreens was open normally 12 hours and it decided to keep open for another 12 hours, we'd have to at least examine, well, how much is one more hour? And then expand that out to 2 hours, 3 hours, 4 hours, 6 hours, then 12 hours. But at least if we understand what the margin is and what it is to go one more unit from the margin, we can then generate ideas about what the best decision is to make. Maybe we may find that we'll take a loss if we go one more hour, in which case we would not want to do that. So we have to carefully consider, if we're in the business of making money, we don't want to throw money away. On slide 6 of 45, people are rational. Economists generally assume that people are rational. Using all available information to achieve your goals, rational consumers and firms weigh the benefits and costs of each action, and try to make the best decision possible. For example, Microsoft doesn't randomly choose its price of its Windows software. It chooses the price it thinks will be most profitable. So if you were to choose a price at $1,000, that might not be rational, and nobody might buy Windows anymore. They would say, let's go to Linux. Whereas if you choose a price at $120, it's definitely expensive, but it is at a level that people will make that investment, and I think that is pretty close to the going price, which Windows does not seem to have stopped in its popularity. Everybody's using it. People respond to incentives, slide 7 of 45. As incentives change, so do the actions that people take. So, for example, changes in several factors over time have resulted in increased obesity in Americans over the last few decades. That includes decreases in the prices of fast food, as in relation to healthful food. In other words, you want to get something super healthy, $6. You want to get something junk, $1 menu, right? Improved non-active entertainment options. So before, in the past, you wanted to have fun, you went out, you played frisbee, you threw a football, you hit the basketball court. Now, I'm not saying that those options aren't available, but maybe somebody might be a gamer who just wants to sit around on their Xbox One or PS4 and play games with their friends online through a network. Increased availability of healthcare and insurance, protecting people against the consequences of their actions. And that's going to be discussed again in the later slide. I think it's going to be discussed on slide 9 of 45, where it talks about a study that was actually done on health insurance and how controlling for other factors, that in fact there was a correlation between that and obesity. But let's go to slide 8. Optimal decisions are made at the margin. While some decisions are all or nothing, most decisions involve doing a little more or a little less of something. This is just their complicated way of saying one more unit at the margin. Right? As we discussed earlier, one more hour. If I produce 1,000 items per day, one more item, right? That's really what they're getting at here. And so the example is given is, should you watch an extra hour of TV or study instead for Professor Claremont's class, because you know that he is a bit tricky in terms of demanding that his students actually demonstrate true knowledge in his course. And so as a result, you say, well, I want to increase my grade from a C to a B or from a B to an A. So I'm going to go ahead and do that extra hour of study instead of watching a show like American Horror Story or Scandal. Economists think about decisions like this in terms of the marginal cost and benefit. The marginal cost being the additional cost of going, say, to one more unit, and the marginal benefit being the additional benefit of going to one more unit. Comparing marginal cost and marginal benefit is known as marginal analysis. On slide 9 of 45, health insurance and obesity. Obesity is arising in America for various reasons. Is one of those reasons health insurance? People with health insurance have less incentive to stay healthy than people without health insurance. Holding constant other factors, right? Because in other words, if these other factors are the cause, we don't want that to pollute our results. We want to know, barring that, taking that out of the equation, how does the availability of health insurance correlate with the amount of people that are obese? And so holding constant these factors like age, income, gender, research shows that people with health insurance are more likely to be obese. They are responding to economic incentives. That's the case of moral hazard that I discussed in class. Moral hazard means that if you have a benefit available to you like insurance, would you then abuse that insurance, right? Would you, if you have a car accident and you don't have insurance to cover your medical bills, you would be inclined to say, I'm all right, I'm not going to the hospital. Whereas if you get into that same accident and you have plenty of good insurance, then you might be like, well, my pinky hurts, nothing else, just my pinky, I'm going to the hospital. So are you now abusing the system because of the fact that you have insurance? Could you be someone who's engaging in fraud? You're doing a swoop and squat where literally you just go in front of somebody and then you jam on your brakes and then it hits you from behind, knowing that if you rear end somebody, the other person who did the rear ending is at fault, right? So that could be abusive in of itself, engaging in insurance fraud because you know insurance is available. What is the economic problem that every society must solve? In discussing how an economy answers questions, the questions we could look at would be what goods and services will be produced, how will the goods and services be produced, who will receive the goods and services produced. And that goes back to our scarcity idea, right? Because he said, should we let everyone have free reign or free access to a resource? Not necessarily, right? And that's why we engage in trade. And trade, which was a barter system, eventually led to the creation of money, and money being a representation of something of value. We use that instead now to make our exchanges, to buy things, right? So what goods and services will be produced? Individuals, firms, and governments must decide on the goods and services that should be produced. An increase in the production of one good may require the reduction in production of some other good. This is a trade-off. And what we mean by that is that we could, say, spend all of our time producing gas, right? So we might be like, okay, you know what? This country is going to only work on drilling oil wells and creating the substance which will be known as gasoline for cars. But we could also at the same time be working on producing electric cars, right? And so as a result, the time we don't spend making electric cars is the time we spend working on drilling oil wells. So there's a trade-off, and we could do the opposite. We could just spend all of our time making electric cars and then spend none of our time making gasoline, in which case then we would have to import our gasoline from another country, right? Because we're going to have some cars that are still going to run on gas. We may produce a lot of electric cars. They may not all be sold in the United States. They may be sold overseas. They may become exports. So as a result, we're going to need that gasoline somehow. So we can either produce that here or get it from abroad, but then we're at the mercy of another country. And so these are things that people think about when they're doing these trade-offs. So the highest value alternative given in order to exchange in an activity is known as the opportunity cost. The example given, the opportunity cost for increased funding for space exploration might be giving up the opportunity to fund cancer research. That was slide 11 of 45. Let's go to slide 12. How will the goods be produced? A firm might have several methods for producing its goods and services. For example, a music producer can make a song sound good by hiring a mediocre singer and using auto-tune to correct the inaccuracies. Or they could hire a great singer and use standard production techniques. So these are options, these are choices. Another example, as the manufacturing labor changes, a firm might respond by engaging in automation, by changing its production technique to one that uses more machines and fewer workers, or move its factory to a location with cheaper labor. And with this, we think of overseas, taking a factory to China, because China, things are very cheap there, because their currency is worth less than our currency. Slide 13, who will receive the goods and services? The way we are most familiar with the United States is that people with more money, higher income, obtain more goods and services, right? Golden rule. The person with the gold makes the rules, right? Changes in tax and welfare policies can change the distribution of income, though people often disagree about the extent to which this redistribution is possible. In other words, are we in some sort of a socialist or communist society, or are we in a capitalist society? Because if we are letting the government come in and redistribute income, people may no longer have incentives. Because they may say, well, what's the point of becoming a doctor? Doctors make a lot of money, but if we redistribute the income from doctors to homeless people on the street, then they may find that, you know what, I'm not going to work so hard if I'm just going to lose most of my income anyway. What types of economies are there? This is slide 14. Central planned economies result when governments decide what to produce, how to produce it, and who receive the goods and services. So a communist system is a form of central planned economy. Market economies result when the decisions of households and firms determine what is produced, how it is produced, and who receives the goods and services. So maybe a place like Hong Kong or something, right? As much as people would say, well, isn't that associated with China? Hong Kong is a relatively free market area where anything goes for the most part. You know, in other words, whatever happens in the market happens in the market. The government does not want to get too involved because Hong Kong has a good thing going on, and they're going to keep on taking advantage of that. Taiwan is another special district in China where a lot of money is made. They're one of the world's leaders in technology, and a lot of that resulted from the fact that despite the fact that central China has a communist government, they've allowed places like Taiwan and Hong Kong to operate relatively freely with market economies. A market itself is a group of buyers and sellers of a good or service. Mixed economies would have features of both. Most economic decisions would result from the interaction of buyers and sellers, but governments play a significant role in the allocation of resources. The United States government is actually an example of a mixed economy, even though it is typically thought of as a capitalist system. To some degree, our government does get involved. If our government gives millions of dollars to commercial farmers, that's a redistribution of income. We're being taxed, and then they feel that agriculture is important to our economy. They're then reallocating the money they receive from taxes to these commercial farmers because they believe it is for the good of the country. That is still mixed as opposed to just being a free market economy. What about the efficiency of economies? We have productive efficiency. We're now on slide 15. where goods and services are produced at the lowest possible costs. Or we have allocative efficiency, where production is consistent with consumer preferences. Allocative meaning, are we able to allocate to each and every person? The marginal benefit of production is equal to its marginal cost. In other words, we have to at least break even at the margin for it to be worthwhile for us to keep going one step further. These efficiencies come about because all transactions result from voluntary exchange. Transactions make both the buyer and seller better off, or in some cases, at least neither are better off than the other. They're both equally unhappy. But nonetheless, that is a settlement, right? Because it is agreed between them that they're going to conduct this deal, and they would not do it unless both felt like they were getting something out of the bargain. Slide 16, caveats about market economies. Markets may not result in fully efficient outcomes. We do have things called market failures. People might not immediately do things the most efficient way. Governments might interfere too much with market outcomes. Market outcomes might ignore the desires of people who are not involved in transactions. For example, pollution, right? If I'm a business owner and I am dumping my waste, you might not be a consumer of my business, but my waste is being dumped in your backyard regardless. You are still being affected by something that is occurring in the market. Economically efficient outcomes might not be the most desirable, right? Because, again, going back to the pollution example, it may be economically efficient for me to dump waste in your backyard and not care. But people would be screaming bloody murder, right? Like, why should we be exposed to cancer and other types of diseases or illnesses if it makes you better off, but it doesn't make me better off? So it's economically efficient for you, but that doesn't mean that it is beneficial for me. Markets could result in high inequality, right? The 1%, the 2%, the top 5%, right? The rich stay richer. Some people prefer more equity, which is a fairer distribution of economic benefits. But when you're in a freer system, there's less interference with that. And so as a result, there may be periods of high inequality. And that's considered okay because we consider that to be income that was acquired through shrewd market transactions. We're on slide 17 now. We're understanding the roles of models in economic analysis. Models are simplified versions of the world expressed mathematically. Slide 18, economists develop economic models to analyze real-world issues. Building an economic model often follows these steps. Number one, we decide on the assumptions. Number two, we formulate a testable hypothesis. Number three, we use economic data to test the hypothesis. Number four, we revise the model if it fails to explain the economic data. And number five, we retain the revised model to answer similar economic questions in the future. So, what does that mean in a nutshell? Well, let's think about that. We're developing a model. We're deciding on certain assumptions. So, our assumptions might be that, okay, if let's say my hypothesis had to do with the death penalty, right? And I have a theory that for every person we put to death, crime goes down, right? Because people are scared, because now they realize, oh, I better follow the law because I don't want to be sent to prison for a long time or put to death for the more serious crimes. Does crime act as a deterrent? Those are assumptions, right? Because it's not intuitive that necessarily the death penalty deters crime. It may deter it, it may not deter it. But if we assume that it does deter it, then that's an assumption we made to develop that kind of a model. We formulate a testable hypothesis, which means that if I'm going to contend that the death penalty helps crime to decrease, then I'm going to say, let's take the number of people executed and let's compare that against the crime rates in the days and months after the executions take place, that same time period, so to speak, and let's see if there was a change. We can measure that based on statistics about what the crime rate currently is versus the recorded amount of deaths that occurred as a result of execution. We use economic data to test the hypothesis. Any data that we obtain, we could obtain data from the FBI, from the Bureau of Crime Statistics. That would be considered economic data being used in that circumstance to test our hypothesis, right? And then if our model fails to explain economic data well, we might change it. So we might say, well, maybe it's not all crime that goes down. Maybe property crimes will still take place even with the death penalty. But maybe crimes like robbery, rape, and murder will go down because we know that those crimes are the ones that actually could be punished by the death penalty, although not so much a rape because the U.S. Supreme Court made it unconstitutional to execute someone for rape. But definitely crimes like felony murder, which a robbery could lead to a felony murder, or actual murder, right? Cold-blooded murder can definitely get the death penalty in certain states. And then eventually we retain and work with the revised model to answer similar economic questions in the future. So if we were to determine that, in fact, the death penalty is successful in reducing certain types of crimes, then when similar questions in the future arise in criminal justice, we might use our findings to help build a case for punishment that results in deterrence. We're on slide 19 now. Important features of economic models. Assumptions and simplifications. Every model needs them in order to be useful. I said that at the beginning of our discussion on models, that they have to be simplified forms of the world. Testability. Good models generate testable predictions which can be verified or disproven using data. That means it has to be mathematical. Even though they don't say it outright, how else are we going to do it, right? We're going to take qualitative data. I mean, we could, but that's risky, right? But that's not impossible. I'm not going to say in all circumstances that there has to always be quantitative data. There could be opinion surveys, and the opinion surveys would technically be the result of qualitative data in the forms of responses from the survey subjects. So in other words, if some rate this service awesome or excellent versus just good, or versus satisfactory or fair or poor, that would be qualitative data that could be used to test a prediction, but more likely than not, it's going to end up being quantitative. And then economic variables, something that is measurable, that can have different values, such as the income of doctors, which again leads back to the idea of quantitative data versus qualitative data, because it's really hard to work with a qualitative variable, right? Because all you really have is options, but you're not going to have a way to mathematically manipulate that in a meaningful way to come to certain conclusions. So definitely you want to have something with good mathematical variables in your model in order to really make predictions. In doing this, on slide 20, we're looking at the scientific nature of economics. Economists try to mimic natural scientists by using the scientific method, but at heart, it's still a soft science, right? It's a social science. We're studying the behavior of people, and that's tricky. And so when analyzing human behavior, we have to distinguish between positive analysis and normative analysis. Positive analysis, which is what most of economics is concerned with, is what is. So in other words, we're trying to discover the truth. Normative analysis is what ought to be, which is what we desire, but not necessarily the truth. And we have to be careful with that because we're making value judgments, and we don't want that to bias or taint our studies. We want to be as very objective as possible to report real-life phenomena. You know, what ought to be could probably be more the study of policy analysis. If I were a government making policies, then if I'm trying to determine what ought to be, then I would first begin with positive analysis, determine what is, and then determine, is there any relationship going on, and how do I use that relationship to my advantage to get the result I want. So as indicated at the bottom of slide 20, economists generally perform a positive analysis. Going to slide 21, should medical school be free? Forecasts indicate a significant shortage of doctors, especially primary care physicians, by 2020. High cost of medical school may prevent some people from becoming doctors, lead some people to pursue lucrative specialties instead of primary care. Would more people become primary care physicians if medical school were free? And if so, would it be worth the cost? Economic models can find answers to the positive aspects of this debate. So what are we getting at here? What we're getting at is that specialists make more money than primary care physicians. And because they make more money, people may want to specialize, may want to become pediatricians, obstetricians, oncologists, heart surgeons, different types of lucrative specialties that make more money. And people don't generally have access to these specialties, unless they have a special condition. But they still do need to at least go to a primary care physician on a regular basis, because it's usually the primary care physician that is the gateway doctor that's going to determine if we should need a specialist down the line. So we need a lot of primary care specialists, and those are the general practitioners. How do we get people to become more general practitioners? Should we make medical school free? And if so, what would be the cost? Economic models can find the answers to this, but just telling you off the top of my head, if we made medical school free, we are not guaranteed that people will still want to become primary care physicians, right? Because I could take the free medical school and say, hey, thanks, I'm still going to become a heart surgeon. So we have to be careful, right? We have to think it through about whether or not this is really going to achieve the objective we want. So now we go to slide 22. And we're distinguishing between microeconomics and macroeconomics. On slide 23, we see that microeconomics is the study of how households and firms make choices and how they interact in markets and how the government attempts to influence their choices, right? So we're studying individuals, firms, households. Macroeconomics is the study of the economy as a whole, including topics like inflation, unemployment, economic growth. Now we're studying a country as a whole, or even the world as a whole. So macro is on a very expanded, generalized level that takes into account a country or the world, whereas microeconomics looks at individuals and consumers and firms. Slide 24, we're going to define economic terms. When we reach slide 25, we're told that fields of study, like say, sociology or philosophy or law even, that the economics being a similar field of study, it uses terms or jargon with specific precise meanings. So you have to be careful not to use the real world meanings and to use the economic specific meanings. Sometimes these terms will be used in ways that will differ from closely related disciplines. So in other words, if you, in one field, this might mean this, but in another field, it might mean something else. So example would be technology. In economics, it specifically means the processes a firm uses for turning inputs into outputs of goods and services. And capital means manufactured goods that are used to produce other goods and services, right? So in other words, if I buy a machine that helps me to make bottled jelly, right? That would be considered my capital, because it's, even though I purchased it, it has a very specific use, which is that it's being used to make other goods and services in my factory production. So therefore, it is really considered capital. Pay close attention to the terms defined in class and in the textbook. Slide 26, common misconceptions to avoid. Believing economics is only about money, right? Because actually, when I gave an example earlier, I talked about the death penalty. And that's not really about money necessarily. It could be, though, right? Because obviously the death penalty could be expensive as well. But the way that I described it, I was only just merely talking about whether or not the death penalty had an effect on people committing crime. That really had nothing to do with money, per se. Not directly. confusing positive and normative analysis. Don't confuse what is with what ought to be. And assuming familiar terms for, or meanings for, economic terms, right? That we just discussed that. Just because you may believe that something means something in another context, don't think it has the same meaning in the economic context. Now we are in the appendix portion of chapter 1. In other words, we finished the main material, and these are additional items in chapter 1, but we definitely need to go over them because they're important for the class. So we're using graphs and formulas. So we go to slide 28, and we see that maps are an example that's given to us. These are simplified versions of reality. In other words, the map doesn't give you a whole lot of detail. It doesn't tell you what buildings are there, how tall the buildings are, what the street looks like. You know, that you'd have to use like Google Earth or something to get that sort of street level view from the satellite high in the sky. The map is just a very simplified version of how the area looks, right? They give you a street map of New York City there, that if you follow that map, you can probably get to where you need to go, but it's not detailed and complex, right? So going to slide 29, we're talking about graphs of one variable. And so we have our typical bar charts and pie charts, right? And the reason it's like one variable is because the horizontal axis, or the x-axis of the bar chart on the left, only really has the names of different categories. So we have the big three: Japanese firms, European firms, Korean firms. These are not necessarily variables in the sense of being quantitative data. They are qualitative data, but they're not variables in the sense that we mean them from an algebra standpoint. And then the y-axis is actually the variable we're measuring, which is percentages going from 0 to 100%. So that's what they mean by one variable in that instance. And then in the pie chart, it's the same thing again, right? Because all we're really looking at is percentages out of 100%. So we're allocating slices of the pie to the qualitative data, which is the names of the categories, right? So the big three is 47.2%, the Japanese firms 35.5%. So again, we're only dealing with one real variable here, which is the percentage, which is the shares of the U.S. automobile market. Slide 30, we're dealing with time series graphs. And here they're showing you something that is a statistical no-no, right? Which is what happens when your graph is not to scale. The graph on the right is not to scale. We jump from 0 to 4.5 just like that, right? And that's not really fair, and that's not good, because that makes our graph look distorted, right? That's why now when you're looking at the graph on the right, it looks more pronounced. Whereas if you look on the graph on the left, where it actually is to scale, we actually start at a 0 point. We go 1, 2, 3, 4, 5, 6, 7, 8, and that's millions of dollars in sales of automobiles. We actually see that it is more like a straighter kind of line that is kind of angled downward, right? And that is a time series graph. Both are actually time series graphs because the horizontal axis, or x-axis, contains years, which are time periods. It could be any kind of time period. It could be months, it could be days. In this case, it is years. And so that's why they're saying this is a time series graph. And these are graphs that we will study in our economic analysis as well. So now we're on slide 31, and we are given graphs of two variables. Now we're looking at quantity on the horizontal axis, x-axis, and price of pizza on the y-axis, or the vertical axis, right? And each point in the grid represents a point of the price and quantity combination. So if we were to represent that, we would say, like in parentheses, x comma y, right? So looking at point A, it would be in parentheses 50 comma 15. And point B would be 55 comma 14, right? So you follow that? So let's go to the next slide, 32. we can then use that data to calculate slope, right? That's an algebraic principle. Slope is equal to the change in value on the vertical axis divided by the change in value on the horizontal axis. Or another way of saying change in is delta, right? The Greek letter delta. So delta y divided by delta x. Because the vertical axis and the y-axis are the same, and the horizontal axis and the x-axis are the same, and we can just simply call that rise over run. So we can use any 2 points to calculate the slope of the line. So now going to slide 33, we actually see that being done. And just the way as I described it, the points are described in parentheses x comma y. So we have a point 55, 14. And then we have a point 65 and 12. And then based on that information, we then are able to determine the slope because the y's are 14 and 12 and the x's are 55 and 65. We usually subtract the point that is to the left from the point that is to the right because the point that's to the left is the starting point, the part that is to the right is the end point, so we're subtracting the starting point from the end point. So that's why we do 12 minus 14 instead of 14 minus 12. And that's why we do 65 minus 55. So 12 minus 14 is negative 2. 65 minus 55 is 10. Negative 2 divided by 10 is the equivalent of negative 0.2. So the slope of that line is negative 0.2. Going to slide 34, we then are able to look at 3 variables on a curve. But how they do it is that we are told that these are the results when the price of hamburgers equals $1.50. If the price of hamburgers equaled $1 or $2, that would be a change. It would be another line, but it would also be on that same graph. And so the fact that we have more than one line is how the third variable comes into play, and you'll see that more clearly on slide 35. So on slide 35, if the price of pizza is $14, an increase in the price of hamburgers from $1.50 to $2 increases the quantity of pizzas demanded from 55 to 60 per week. And so it shifts us to demand curve 2. So we see curve 1 is on the left, right? That has points A and C. And curve 2 is on the right, and that has point B. So the fact that we have changed the price from $1.50 to $2, you know, the $1.50 and the $2 are part of that third variable. And so that's how they're representing 3 variables, even though it's on a 2-dimensional graph. Going to slide 36, we extend it even further by having a line for when the price of hamburgers equals $1. So now we have 3 different values in our third variable, $1, $1.50, and $2. And that is very clearly apparent as now the leftmost line is demand curve 3. Slide 37, positive and negative relationships. As you can see, when we go from left to right, the line keeps rising on the y-axis. That means that there is a positive relationship because of that increasing nature of the points on that line. But if it had been the other way around, where as we went to the right, the points were getting lower, then that would be considered a negative relationship. So positive relationship looks like this, a negative relationship looks like this. And in this figure here that we're looking at the positive relationship between disposable personal income and consumption spending. In other words, the more income you make and that you have available after you've paid your bills, so in other words, that's your leftover money after you've taken care of your major obligations, that's your money now that you could either save or you could spend. And so the studies here show that when people have a lot of personal disposable income, they will spend. Consumption means spending, right? Because even though consumption may mean eating to you, in economics, consumption specifically means the use of some sort of good or service. Slide 38 is our old adage that correlation does not equal causation. So on the left we have a negative relationship sort of line, and on the right we have a positive relationship line. And there are two different scenarios that are being shown here, right? Number of leaves on trees versus number of fires in fireplaces, rate at which grass grows versus number of lawnmowers being used. And so in problem A, it is the problem of omitted variables, right? Just because the number of leaves on trees has a negative relationship with the number of fires in fireplaces, maybe the reason that's going on is because winter is coming. And so because winter is coming, the leaves are falling off the trees, and then people need to keep warm, so they're putting fires in their fireplaces. But if we just studied these two variables without taking the factor of temperature of the winter coming into account, then you would think that the number of leaves on trees cause the number of fires in fireplaces, and that would be a no-no. With panel B, the rate at which grass grows and then the number of lawnmowers being used, that's a problem of reverse causality, right? Because you would be inclined to think that the number of lawnmowers being used increasing means that grass must grow. It's really the other way around, right? It's the rate at which grass grows drives the number of lawnmowers being used, because as grass gets too tall, owners want to cut that grass. But if you were to read that relationship the opposite way, that would become like a reverse causality issue, where it is not necessarily the case that an increase in the amount of lawnmowers then causes grass to grow faster. The relationship between two variables is linear when it can be represented by a straight line, and most of the graphs I've shown you had a straight line, but it's not going to always be a straight line. Few economic relationships are actually linear, but linear approximations are easier and simpler to use and are often good enough in modeling, so you may see a lot of linear approximations being used most of the time, but that doesn't mean it can't be used even in the scenarios of curved lines. There are ways to still approximate, and we're going to be showing that on the next slide. So it says slopes of nonlinear curves on slide 40, and we have this sort of bow, sort of like half bow curve, right? That is positive, right? And it shows total production for various quantities of iPhones, right? Versus the total cost of production on the y-axis. And we can approximate the slope between A and B and C and D by trying to draw a line between the two, and then using that to approximate what we think the slope is at those points in time. So when we go to the next slide, which is 41, you see that being done. They actually draw some lines at a point that touches upon that curved line, and then approximating the normal linear slope of that line. They then will use that to determine what they think the slope is of the curved line at that point. So in the first instance, we're looking at point B. We know that the change in y is 75, the change in x is 1, 75 over 1 equals 75. And for the point C, we know the change in y is 150, that change in x is 1 still, 150 over 1 equals 150. So those are the different slopes at those points in time. And if we go back to the previous slide, slide 40, slide 40, the difference between C and D is greater than between A and B. So we would say the curve is steeper between C and D, right? Steeper as it's getting higher. It's like, steep. Whereas between A and B, it's not as steep, right? So there's a huge difference there in terms of the steepness of the curve. So now we're on slide 42. Percentage change. You take your value at the end point and you subtract your value at the beginning point, and you divide it by the value in the beginning point. Right? Or as it puts there, value in second period minus value in first period divided by value in first period times 100. Right? Because what you're going to get is a decimal. But we know that decimals and percentages are pretty much the same thing. So if I tell you 0.34, you know to tell me 34%. But how we actually do that is we actually multiply 0.34 times 100, and then that will result in 34. And then that becomes the percentage we use. And so they're doing the same thing here to show you the percentage of change. They're taking the difference from the second period to the first period and dividing by the first period to tell you the percentage of change from the first period. If you were to do it the other way around, like we were trying to find the, if you knew that, how do I explain this? I mean, it's still the same formula, but, we would envision that if we started off at 25 and we went to 50, that we in fact had a 100% increase, because 50 minus 25 divided by 25 equals 1 times 100 is 100%, right? But what if it were the other way around? What if we were going from 50 to 25? Then it would be 25 minus 50 divided by 25, which would be negative 25 divided by 25, which would be negative 1 times 100 would be negative 100%. So that would then be a 100% decrease. The other was a 100% increase. Now we had a 100% decrease. And then on slide 43, we are dealt with calculating the area under a curve. We have this this line, which is a negative relationship, right? It is the demand curve for Pepsi, quantity in bottles per month versus price of Pepsi, dollars per bottle. And we want to calculate total revenue in that green box there. So to do that, we have to sort of go up to $2 and then go to the right to 125,000. And we take a box of that, right? And area is going to be for a box like that, base times height. So $2 times 125,000 is $250,000. That is our total revenue based on our demand curve for Pepsi at that point. The next slide, which is 44, we're now trying to calculate the direct area under the curve as opposed to a box that is touching the curve at that point. So now we are going to take 1/2 the base times the height as opposed to the full base times the height. And so looking from the difference between $1.50 to $2, we know that is 50 cents. And the difference from 125,000 to 150,000, we know that is 25,000. So 25,000 times 50 cents is going to be like 12,500, and then multiply by half is going to be 6,250. So that's going to be our area for that portion under the graph, which is $6,250. And so on our last slide, 45, make sure you understand the economic concept the formula represents. Make sure you are using the correct formula for the problem you're solving, and make sure the number you calculate using the formula is economically reasonable. If you're using a formula to calculate a firm's revenue and your answer is negative, you know you probably made a mistake somewhere. That concludes our presentation. And if you have any questions, feel free to email me about the material. Thank you, and have a good one.